This is where electrical energy becomes X-ray energy. Hello everyone. In this video, let's learn how an X-ray machine works and understand its main components. An X-ray machine is a medical imaging device that produces X-rays to create images of the human body for diagnostic purposes. X-rays are a form of electromagnetic radiation with very short wavelengths and high energy. These properties allow them to penetrate the human body and produce detailed diagnostic images. The system is operated from the control console, where the radiographer selects the exposure parameters such as kilovoltage, kV, current, mA, and exposure time, mAs. The high-voltage generator produces the electrical power required to generate X-rays. This high voltage is transmitted through high-tension cables to the X-ray tube. Inside the X-ray tube, enclosed within a vacuum glass envelope, are two essential components, the cathode and the anode. The cathode contains a tungsten filament. When an electric current passes through the filament, it heats up and releases a cloud of electrons through a process known as thermionic emission. A high voltage is applied between the cathode and anode, accelerating these electrons toward the anode at very high speed. The anode consists of a tungsten target supported by a molybdenum stem. The anode rotates at high speed, allowing heat to be distributed over a larger surface area. The molybdenum stem helps reduce heat transfer from the anode to other tube components, protecting them from excessive heat. When the high-speed electrons strike the tungsten target, X-rays are produced through two mechanisms, Bremsstrahlung radiation and characteristic radiation. However, X-ray production is highly inefficient. Approximately 99% of the electron energy is converted into heat, while only about 1% is converted into useful X-rays. To manage this heat, the X-ray tube is surrounded by insulating oil, which helps cool the tube and maintain safe operating temperatures. The generated X-rays exit the tube and pass through the collimator. The collimator contains adjustable lead shutters that restrict the X-ray beam to the area of interest. This reduces unnecessary radiation exposure and improves image quality. The X-rays then pass through the patient's body. Different tissues absorb X-rays to varying degrees. Dense structures such as bones absorb more X-rays and appear white on the image, while soft tissues absorb fewer X-rays and appear in shades of gray. A grid is often positioned between the patient and the detector to absorb scattered radiation and improve image contrast. Many modern X-ray systems also use automatic exposure control, AEC. This feature automatically terminates the exposure when sufficient radiation reaches the detector, helping maintain consistent image quality while minimizing patient dose. The transmitted X-rays are captured by a digital detector. The detector converts the X-rays into electrical signals, which are processed to produce a digital image for viewing and diagnosis. For long body examinations, such as full spine or lower limb studies, a stitch stand may be used to combine multiple images into a single long image. Now, let's understand the exposure factors. kV controls the energy and penetrating power of the X-ray beam. mA controls the tube current and the quantity of X-rays produced. mAs is the product of tube current and exposure time, and it determines the total amount of radiation produced during the exposure. By carefully selecting these exposure factors, radiographers can obtain high-quality diagnostic images while keeping radiation exposure as low as reasonably achievable. Thank you for watching. We hope this video helped you understand how an X-ray machine works and the role of its major components in producing diagnostic images. If you found this video helpful, please like, share, and subscribe to Biomedical Hub for more content on medical imaging and biomedical equipment. See you in the next video.